All right, we're going to move on to section 2.1, and 2.1 has to deal with quadratic functions. And typically in a Math 3 or Algebra 2 course, you spend maybe a week on quadratic functions, if not a whole chapter, and we only get to spend one section on it. Okay, so there's going to be a lot of information. So please kind of follow along and take some notes accordingly. All right, so first things first, what I call vertex form, and actually it's very convenient to call it vertex form because you can write it, you can identify the vertex. It's just given by this. F of x is equal to a, x minus h squared plus k. H comma k is your vertex, hence the name, vertex form. And of course, if a is positive, right, your parabola, you already know, is going up. Okay, so there's a configuration. If a is positive, sometimes you call it concave up. So here's h, here's k, this is the vertex. In your homework, you might be asked to find the max or min later on in the context of a word problem, right? In this case, if a is positive, right, you're going to have a minimum. And the minimum right here is just the y value of the vertex, okay? And we'll talk about if a is less than 0, right? It's going to have a maximum. Okay, by the way, your book calls it standard form. I don't know why they do that, but in this class, I'm going to call it just vertex form. Okay, so the equation number 1 of a parabola, or otherwise known as a quadratic function, is a parentheses x minus h squared plus k. H comma k is your vertex. It's also nice to be in this form because you can do a comparison with the parent function, right? If you're ever asked, compare this with the parent function of x squared, you can say, hey, if a absolute value of a is greater than 1, vertical stretch, absolute value of a between 0 and 1, vertical shrink, right? Shifted h units left or right, or k units up and down. Okay, so vertex form is one form. Another form, and this one we're going to spend a little bit more time talking about, is called standard form. By the way, your book calls it general form, okay? Book calls this general form. So on a quiz or test, stick with the notation that I give you, okay? Vertex form, standard form. All right, well, standard form is just given by this. Ax squared plus bx plus c. Basically, the way you go from vertex form to standard form, you can go from any form between forms. The way you go from vertex to standard is you FOIL it, right? Square the x minus h, distribute the a, and that's how you go to standard. The way you go from standard to vertex, which I will do an example later, is by completing the square. All right, so for this one right here, if a is positive, right, the parabola is going up, right? If a is less than 0, the parabola is going down. That information doesn't change on this problem, okay? So if a is positive, right, I'll write this again. If a is less than 0, it's going down. Okay, so the question is, right, what is the vertex? Question mark, what's the vertex? You could look up the formula, but actually I'm going to derive the formula here with you. So let's derive it. I'm going to take my f of x is equal to ax squared plus bx plus c. Okay, so remember I said to go from standard to vertex, right? You complete the square. So let's do that. So this is good practice in completing the square. What I'm going to do right now when I complete the square is I'm going to divide by a from both of these terms. Okay, so in other words, factor out that a. And if you factor out the a, you have x squared, right? B divided by a is just b over a, x, okay? Plus c. All right, first line is to factor out that a. And now, right, to complete the square, remember this coefficient right here needs to be a 1, so we made it a 1. What we're supposed to do, right, is to figure out the value, right? We have to add something over here. That completes the square. Right? We need to add, and perhaps we also need to subtract here. Let me erase this really quickly. we also need to subtract something, okay? So I'll leave that blank here. All right, so this is the question mark. What do I need to add and subtract, right? Okay, so if you remember completing the square, this is good review. I take b over a, step number 1, right? This should be b over a, I should say. I take this coefficient right here, and I divide by 2 or multiply by 1/2. Okay, so I'm going to get b over 2a. And then step number 2, after I divide by 2, I square it. Okay, so this becomes b squared over 4a squared. And this is the value that's going to complete the square. So I'm going to go back to my question mark. Oops. Let's try that again. I'm going to go back to my question mark, and I'm just going to erase over here. I already know what I'm going to add and subtract to complete the square. And I'm going to add b squared over 4a squared. B squared over 4a squared. If I add by b squared over 4a squared, I also have to subtract to maintain equality. Right? If I say maintain the value of 8. If you add 8, you have to, let's say you have a number 8. Let's say you add 3, then you also have to subtract 3, right? You're still going to get 8. So same concept. If I add by this value, I also have to subtract by that value. All right, so where's this all going? Now this guy right here is a perfect square trinomial, right? This is a x plus b over 2a quantity squared. And this is c minus b squared over 4a squared. Okay, so this might not look like much, but believe it or not, this is your h, and this is your k, right? And so the vertex, if I say, what is the vertex? You would say, well, Mrs. Zhu, the vertex is negative b over 2a, comma, c minus b squared over 4a. Okay, so that is where, b squared over 4a squared. That is where the vertex formula comes from, okay? So we're going to go back right here. Typically, when you learn this in Math 3 or Algebra 2, right, you wrote x equals negative b over 2a. To get the y value, you plug this back in, okay? So instead of writing this whole expression, right, instead of writing this whole expression, what I'm going to do for my vertex is just write, negative b over 2a f of negative b over 2a. Okay, so this just means whatever x value that you get for the vertex, you plug it back in to get the y value. All right, so if you were able to understand all this, that means your algebra skills are strong and you remember how to complete the square. All right, so that is what we call standard form, and this is where the vertex formula comes from. Okay, you complete the square. All right, we're going to move on to intercept form. So I believe this was number 2. And we'll call this number 3 here, okay? Intercept form. All right, intercept form is just given by this. A, x minus p, x minus q, okay? The x-intercepts are p and q. You have p comma 0, and then q comma 0. Okay, it doesn't matter what I call it. So if I were to graph this, right, on the first and fourth quadrant, I also need a vertex formula, right? We'll call this p right here, and we'll call this q. Okay, so those are my x-intercepts, p and q, okay? All right, so what is the vertex formula if it's an intercept form? Well, instead of just giving you the formula, right? Okay, the vertex is right here. I want you to think about it, right? This guy right here, this point right here has the same distance to the, this is called the axis of symmetry, by the way. Okay, I forgot to mention that. Your AOS, right, is the x value of the vertex. We'll talk about what that is in a second here. So P has the same distance to this axis of symmetry. Q has the same distance to axis of symmetry, right? If these distances are congruent or the same, right, the vertex formula is just P plus Q, right, divide by 2 because it's the midpoint. And to get the y value, again, use function notation, plug this back into the original equation, okay? So your AOS is just P plus Q over 2 if it's an intercept form. So by the way, if I go back to my first line right here, right, my AOS, excuse me, your AOS is just x is equal to h, okay? So it just depends what form you're in. And there's one last thing I want to just kind of going back to standard form. You know, the vertex is given by this formula. The y-intercept, right, if you plug in, you know, f of 0 over here, the y-intercept is just 0 comma c, okay? Just this last number right here. Okay, so we've covered 3 different forms so far. And you need to be familiar with all 3 forms. And you need to know how to go from form to form, right? If I say, hey, convert from intercept form to standard form, how would you do that? You would FOIL, right? I mean, basically, this is a binomial, and I FOIL and multiply by a, right? All right, so this configuration, right? Again, a is less than 0, you can see, right? This parabola is going to go down. This guy right here is going to have a maximum, okay? It's going to have a maximum. If the parabola is configured down, is concave down, it's going to have a maximum. And the maximum, right, is just, again, the y value of the vertex, okay? And the minimum, just to review, right, is the y value of the vertex. If the parabola is going up, it has a minimum. If the parabola is going down, right, it's going to have a maximum. It refers to the y value, okay? All right, so hopefully that was a good review for you. Hopefully this is not something you haven't seen before, but you're welcome to replay it in case you missed some details.